Hello guys, this is Dr. Maha Abdurrahman, the founder of Chemistry for Life platform, and that's the second tutorial for atomic structure and periodic table for the IGCSE curriculum. Now let's start with the first question. The first question about element M. Element M has the following electronic distribution. Which group in periodic table is M likely to be in? Now, since this is the electronic distribution in the last energy shell or the last electronic shell, so since it has 3 electrons, that means that element M is likely to be in group 3. Because as we all know, the number of electrons in the outer shell reflects the group number in the periodic table to which this element belongs. Predict whether element M is a poor or a good conductor of electricity. Now, since group M is in group 3, we all know that group 1, 2, and 3 are metals, so that means element M is a metal. Since element M is a metal, so I would predict that element M is a good conductor of electricity, as we all know that metals are a good conductor of electricity. Binary compounds contains 2 atoms per molecules. Identify an element which could form a binary compound with element M. Well, that's a kind of tilted question. Binary compound, so it just has to have 2 atoms per molecule. So I need to think of another nonmetal that would react with M, which is in group 3, to form a molecule that has only 2 atoms. That means I should think of, since M is in group 3, right? So that means the valency for M is 3. So I should think of another nonmetal, I would say in group 5, to have this molecule as a binary compound. Why? Because in group 3 needs to lose 3 electrons to have a complete outer shell. For group 5, since it is in group 5, we all know that group 5 needs to gain 3 electrons to have a complete outer shell. With that being said, that means that M will form positive 3 ion, and whatever element in group 5, it's gonna gain 3 electrons, so it would have a negative 3 ion. Positive 3 will cancel out negative 3, so I would have a binary compound. So that means the other element or the other nonmetal should be in anything in group 5, right? So I would say nitrogen is correct. You can also still write phosphorus or any element in group 5. Predict the formula of the sulfate of M. He helped you here. He gave you the formula of the sulfate ion, which is SO4 negative 2. Now, what does this negative 2 mean? This negative 2 means that the sulfate group ion has 2 extra electrons. It has 2 extra electrons. And since M needs to lose the 3 electrons, the sulfate needs to gain 2 electrons. So the formula would be M2, because I need 2 molecules of the metal, and the sulfate would be SO4 all to the power 3, because I need 3 molecules of the sulfate group to cancel out the charge for the M metal. Now, I'm gonna elaborate that more, because here when you have 3 of the sulfate, each one with negative 2, so negative 2 times 3 equals negative 6, so that's the total charge at this side. On the other side, I have positive 3 times 2, it's gonna be positive 6. So the total charge on the M side is positive 6, providing I have 2 of the positive ion. And on the sulfate side, providing I have 3 of the sulfate group, each one has a charge of negative 2, so the total charge would be negative 6. Those two charges would cancel each other, so that means my prediction for the formula is correct. Now moving to the other question. The hydroxide of M is a white powder which is insoluble in water. Describe how could you show that the hydroxide is amphoteric. I'm gonna skip this question for now because it's out of the scope of the atomic structure and periodic table which I'm solving right now. We're gonna postpone it later. This question as well is an easy one. It's a good chance for you guys to collect marks. Now the table below gives the number of protons, neutrons, and electrons in atoms or ions. Complete the table. The first line is given as an example. You need to use the periodic table for that. Obviously, we need the periodic table to identify the elements. Okay. Now, which element has, actually, I'm gonna use the proton number to identify the element because we know that the proton number is specific for each element. So the element that has proton number 4 is the beryllium. If we use the periodic table, we would see that the element that has proton number 19, and I'm just gonna use the proton number to identify the element, is the potassium or potassium. Both pronunciation is correct. So it has the atomic number or the proton number of 19. And since the electron number is 20, okay, so that means, I'm sorry, the electron number is 18. Since the electron number is 18, that means it's missing an electron. So I have to put the positive charge up here because it is missing an electron. The number of neutrons is 20. If I add that to the 19 over there, I need to add those two to get the mass number which is written up there. So the mass number would be 19 plus 20 is 39. Okay? Here you can get the full mark. Please guys, don't forget the charge over there. Don't forget to write the proton number correctly and the mass number as well correctly to gain the full mark. Now, moving to C, what's the element that has number of proton 30 and the electrons are the same, 30? That means this is not an ion, that's an atom. And this atom is the zinc. The zinc has 30 protons and the number of neutrons are 35. So I'm gonna add these two. 30 plus 35 will be 65 is the mass number. D has 8 protons but 10 electrons. That means it is an ion of -2 because there are 2 more electrons than the protons and the symbol is oxygen. Oxygen has 8 protons and because there is 2 extra electrons, I'm gonna add the -2 over there. And let's add the 8 to the 18 to have the mass number of 16. So this is the number. Again, guys, don't forget the -2, don't forget the 8 and the 16 over there. Now let's move to the last one. 31 is the proton number and the electron number. That means this is an atom, not an ion. And if you go to the periodic table, you will find the element that has 31 protons is the gallium, Ga, 31. And let's add the neutrons to the protons to have the number 70, which is the mass number. This is an easy one to accomplish, and luckily it has 6 marks. You can easily gain those. Now let's move to the other question. Using the data in the table, explain how you can determine whether the particle is an atom, negative ion, or positive ion. Another good chance to gain marks, because that's simply explanation for the question before. Okay, so whether it's an atom, it's very easy. That one is quite easy question. We all know that for an atom you need to have the number of protons equal to the number of electrons. Now for the negative ion, I have always the number of of protons are less than the number of electrons, right? So the number of electrons are more. And for the positive ion, I have the number of protons obviously is more than the number of electrons. So that was a quite easy question. Now let's move to another. That question is very funny. I love those kinds of questions. They're kind of collective question from a couple of chapters, and I like those kind of questions. They're also it's easy also to acquire marks for those. Name the element which matches the description. It's kind of like a clue. It's used as a fuel in the nuclear reactor. That one is the fuel in the nuclear reactor in the isotopes part. I would say uranium. It's even like general knowledge. It's the only non-metal which is a good conductor of electricity. It's a non-metal that is a good conductor of electricity. I would say the graphite, which is form of carbon that we all know that it can conduct electricity due to the free electrons. I don't want to go in details into the structure of the graphite, but this is something that we all know very well during our study in this chapter. Also, if you write carbon, that's fine, but I would say graphite is the best answer. It's better because not all forms of carbon can conduct electricity. If you take the diamond, for example, it does not. So I would go for graphite. I would say this is the best answer. Inert electrodes are made from this metal. Inert electrodes, they do not react in the electrolysis. This question is from electrolysis part. That's why I told you this question is a collective one, but it's not hard. Inert electrodes like the platinum, okay? These are one from the inert electrodes. That's the most common. And you can say gold as well. Gold is quite a reactive metal. The gaseous element is used. Now, one of my students for that question, they said, I just want to share that with you. I remembered it right now. Can I write carbon? Carbon is an inert electrode. It's a very common inert electrode. But for this particular question, we cannot write carbon. Why? Because carbon is not a metal. Here they need a metal. That's the only reason why I cannot write carbon as inert electrode. This gaseous element is used to fill balloons. Everybody knows that. In preference to hydrogen, of course, it is the helium. Okay, we have used that in birthday parties. That's a well-known noble gas that's used to fill balloons. An element which can form an ion of type X -3. That means it is a nonmetal that can gain up to 3 electrons, and that is one of the any group 5 element or group 5 ion. So I would say this element is, I can say nitrogen, phosphorus, any of those answers are correct. Now let's move to, it has the same electron distribution as calcium ion, so I just need simply to get something from this, or some ion from the same group. I would go for same electronic distribution as calcium ion. I would go for, it's not from the same group, sorry, it was a mistake, typo, typo mistake you can call. I meant from the same period. If you go from the same period, I would choose potassium. It's in the same period as calcium, because potassium, when it loses one electron, it becomes like the noble gas argon, okay? And calcium as well, when it loses 2 electrons, it becomes like the noble gas argon. So can I write argon as an answer? Yes, we can write argon, we can write potassium, we can write calcium. Anything that has the same electronic configuration we can accept, okay? So those three has the same electronic configuration. Obviously, I cannot write calcium because they want something that is similar to the calcium, so I'm gonna write argon or potassium ion. Both are correct. The element is in period 5 and group 5, 6, and in group 6, period 5 and group 6, just check the periodic table. You will find that the tellurium is the 1. Now moving to the other question, number 4. Define diatomic. Define diatomic. Diatomic molecules are the molecules that have 2 atoms per molecule. That's right. So I would say diatomic, it's a molecule. First of all, it is a molecule that has 2 atoms. All of us know that the group 7 or the halogens, they are nonmetals that are all diatomic. What do the electron distribution of halogens have in common? Obviously, halogens are in group 7. They all have, since in group 7, they all have 7 electrons in the outer shell. How do their electron distribution differ? How do the electron distribution differ by the number of energy levels? So they have, obviously you know that each period have an extra electron shell, okay, so it has an extra energy level, so they have different, you can write number of energy levels, or you can say they have different number of electron shells. Okay, now this table is very common about the halogens, chlorine, bromine, and iodine, whether they're solid, gas, or liquid. As we go down, the melting point increases, okay, the particles get more closer, so I can predict that chlorine is gas, then bromine is liquid, since we said the particles gets closer, and the color gets darker. The iodine is solid. The color gets darker, so going from yellow to brown to black. Okay, so that means the color gets darker. They can also accept gray for the iodine. Okay, now let's move to the other question. The other question is about drawing equivalent bond. Okay, now the halogen reacts with other nonmetals to form a non-covalent compound. Draw a diagram which shows the arrangement of the valency electrons in one molecule of the covalent compound of arsenic trifluoride. The good thing that they gave you the name, and the name is self-explanatory. You can just predict the formula. Arsenic trifluoride, this is the that means it has 3 atoms or 3 ions of fluoride, to be more specific. Then also they help you by giving the electron distribution of the arsenic atom, which is over there. That means it has 5 electrons in the outer shell. Use X to represent the electrons from arsenic. You guys have to abide to those characteristics or those forms of the electrons when you draw, and the O to represent the electrons from the fluorine atoms. So simply I need to draw the arrangement of valency electrons only. I already know that the arsenic has 5 electrons in the outer shell, right? So, and I'm gonna represent them by X's. So I have, that's the circle for the arsenic. I have 1, 2, 3, 4, 5. 5 electrons for the arsenic. For the fluorine, I'm gonna refer to it with red. I have 1, okay, 1 fluorine, the second fluorine, and the third fluorine. Okay, those are the bonding electrons. That's why I'm gonna write them in common. Maybe not, that one is not really accurate. I'm gonna remove it and draw it inside to be more accurate. Yes, the electron has to be inside because this is the bonding electron. So here I have 1 from the fluorine, 2, 3, 4, 5, 6, 7. Why I'm choosing 7? Because fluorine is in group 7. That means it has 7 electrons in the outer shell. So I have 1, 2, 3, 4, 5, 6, and that's the 7 over there. 1, 2, 3, 4, 5, 6, and I have my 7 over there. So this is the arsenic fluoride. It's simply like that. Okay, but they want you to draw the diagram, the dot and cross diagram. I prefer this, which is the dot and cross diagram, to show how the bonding electrons are. This one will not show me the bonding electron, but you can just draw it for yourself as a guide before you draw this, but this is the correct one. Okay, because that one what shows the valency electron, or where are the valency electrons and how many are those. This is just a structural formula that does not show that, so I would go with this. The name here is dot and cross diagram. For those who don't know, we call this diagram dot and cross diagram. It's the one that shows the electrons in the outer shell, or the valency electrons. Now this question, I'm gonna skip it. Photochromic glass is used in sunglasses. This is in chapter redox, okay, and I'm gonna cover this chapter with the question later on. It's not related to what I'm doing right now. And now I have question 5, 6, and 7. I will postpone question 5, 6, and 7. They're on the same topic, but I'm gonna do it in another video, because based on your request, you guys asked to have a more frequent but short tutorials, because I know not everybody has the time to listen to a half a minute to a half an hour or an hour video. So I'll try to make my videos between 20 to 30 minutes maximum. Okay, so I don't want to make the video too long for you, just to be able to see my videos more frequent. So just stay tuned. Maybe I'll post the other half of the tutorial maybe like by next week. Thank you so much. Have fun. Have a great day or evening if you're at night, and see you next time in the next video. Thank you.